Hi guys, this is Mrs. Allison. Today we are going to multiply monomials by polynomials. Really what we get to do is put into practice some of those exponent rules that we worked so hard on last unit. So to multiply a monomial and a polynomial, all we really need to do is to distribute the monomial into all terms of the polynomial. So whatever that happens to be, all terms need to be accounted for when we do the distributing and when we multiply. Now, when there are exponents, and this is where those rules come in that we've been practicing so long, for those exponents, we're going to use the product rule. Okay, well, it has been a little bit of time, so what exactly is the product rule? Remember, the product rule says this, that if I take x to the a and I multiply it by x to the b, meaning my bases are the same. That's the key there, is that my bases are the same. When I do that, this answer will be x raised to the a plus b. So remember, if we had an example like 2a to the third times 3x, I'm not actually sure why I did a, but let's do 3a to the fifth. Because these bases are the same, remember we take and multiply 2 times 3 to get 6. It would be 6a, and then I just add the 3 plus the 5. So we would add the 3 plus the 5 there, and my result would be 6a to the 8th power. Okay, well, now that we have that review out of the way, we need to remember that our answers need to be in standard form. We just finished the idea of standard form. What does it mean to be in standard form? It means that the highest exponent's listed first, and it goes alphabetically. So we go down with like x squared, and then x, and then no x's. So highest exponent's listed first. Okay, so I'm going to try or show you two, and then you're going to try some. So let's look at example 1. Example 1 says x times x plus 4. I know that to multiply a monomial, which we have right here with x, by a binomial, which is a type of polynomial, so a monomial by a binomial, I need to take and distribute the x into both terms or all terms of that polynomial, so all terms of that binomial. Now, I probably would skip this step that I'm about to show you, but I want you to be able to see it. I am taking and multiplying x times x plus x times 4. So I'm taking x and multiplying it by both things in the parenthesis. Now, it's a little bit silly. We don't typically leave it like this, x times x. X times x, I add my exponents, I'm going to get x squared plus, this will be 4x. Now, x times 4 is technically correct. It's not wrong. You're still multiplying the same two things. It's just a little bit like saying I is hungry. It's not really how we speak. It's not really how we write math. It may get the same point across. It just sounds a little weird. So my answer would be x squared plus 4x. And as long as I am in standard form, meaning my highest exponent's listed first, and then my next highest exponent, and then anything after that, I'm done. Okay, well, let's try one that's a little bit more fun, shall we? Just multiplying by an x on the outside, not that exciting. So let's try this next one. We have 5m cubed that I want to multiply by 3m squared, and by negative m, and by negative 7. If I were to write out the step of the multiplication, it would look like this. 5m cubed times 3m squared minus 5m cubed times m minus 5m cubed times 7. And you could put parentheses, you could put a dot. It doesn't really matter. I happen to put parentheses this time. Now, we should notice that this expression of 5m cubed times 3m squared looks an awful lot like this one. And what I should also notice is that my bases are in fact the same, so I can multiply my normal numbers and then add my exponents. 3 plus 2 is 5. Now I'm going to do the same thing over here, but what's the one thing I need to remember? I need to remember, and it's worth putting a star by, kind of like we did on first, this still has an exponent of 1. We can't forget that. That needs to have that exponent on there. Multiplying this would give me negative 5m to the 4th power. And then finally I would multiply these two, but there's no other m's to add it to. So this would be minus 35m to the 3rd. And as long as my degrees go down in order, so 5, 4, 3, keeps going down, I have done this correctly. This is multiplying a monomial by a polynomial. So now it's your turn. Now you get to try some. I would like you to, with your seat partner, try the rest of the examples. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's quite a few. And let's see how we see how we do with these. And then we'll come back together. So hit pause, try them. They shouldn't take you very long, and then we'll come back. All right, if we try this next one, if I take and multiply the k by the k and the k by the negative 9, and if you want to write it out, great. If you want to skip that step because you know k times k is k squared, and k times negative 9 is negative 9k, and leave this as your answer, that would be great. Okay, let's keep going. 9a times a and 9a times 1. (9a times a). I notice that they both have an exponent of 1, which means I need to add them. So I get 9a squared plus 9a when I multiply 9a times 1. And that should be your final answer. We're in descending degree order, so we're in a good place. Okay, we just need to be careful of what I'm distributing. We are distributing this whole term, so this negative 6p needs to go into both terms. Why is that important? Because I've got negative 6p times p to the 4th minus, because the original problem had a minus in it, but I'm minusing a negative 6p times 8. So multiplying all of these, we would get negative 6p to the 5th plus 48p. How do we do? All right, if maybe you didn't do great initially and now you're like, oh, I'm getting the hang of it, hit pause and try the rest of the examples. Otherwise, keep going and let's see how you did. All right, on this one, I would get 3c to the 5th times negative 2c minus 3c to the 5th times 5. When I take and distribute, remember I'm distributing the whole thing, the whole monomial into all the terms of the polynomial. Combining, we'd get negative 6c to the 6th minus 15c to the 5th. Great, we're going to keep going. If at any point you want to hit pause and try to correct some of the ones you've done, go for it. All right, last one that we're going to multiply by a binomial is negative 4g squared times 2g and times 7. Oops. 4g squared times 2g and a negative 4g squared times 7. My first terms together, remembering I have an imaginary exponent there, would be negative 8g to the 3rd, because remember we just said this had an imaginary exponent and 2 plus 1 is 3, plus or minus, depending on how we want to look at it, negative 28g squared. And this would be my final answer here. Okay, well, on this next one, example 8, I see a little bit trickier because I only see 3 terms. But just like the directions set up top, my monomial needs to go to all terms, not just two terms. It doesn't matter how many terms are in there. I need to multiply all terms. So when I multiply these, I would get x times x squared minus x times x plus x times 3. And multiplying all of these, not forgetting my little imaginary 1 exponents, I would get x cubed minus x squared plus 3x. And you'll notice oftentimes my polynomials are in standard form to begin with, just based on how I distributed. All right, example 9 gets a little bit trickier, doesn't it? Because now my term is p squared q cubed. We have both that needs to go into both terms. Okay, what might that look like? P squared q cubed, p to the 5th q squared, minus p squared q cubed, it's kind of a tongue twister, times pq. Please don't forget your imaginary ones or the ones that are there, even if we don't write them. When I distribute these, we would end up with, well, I'm going to do the p's with the p's. So we'd have p to the 7th. And then I'm going to do the q's with the q's to get q to the 5th on this first one. And I'm going to subtract from it p, see my p's, I have a total of 3 p's, p to the 3rd. And then with my q's, I have a q to the 4th. And the only way I can combine these, the only way I can subtract these is if my exponents are the exact same. I would need another p to the 7th, q to the 5th. Well, that's not what I have. I have a p to the 3rd and q to the 4th, but I can't get that over here. So there's no way that this can be simplified anymore. All right, hit pause and try example 10 and 11 and 12 if you haven't had a chance to try them already. All right, example 10. It does get a little bit stranger with that xy, kind of like with the p and the cube before. But I'm just going to make sure it goes into all terms. And you guys, if it helps you to write this step, do it. Show each step. We're taking and multiplying 3xy by all of the terms on the inside, all of the terms of the polynomial. And then I can worry about their exponents, if they have just an imaginary 1, even though it's not written, and what that looks like for combining these terms. So this first one would be 3x cubed y. 3x cubed y, because I have 1x here and 2 x's here, which make it x cubed. And only one y, so I'm going to keep that there. The next one, I get 3x squared y squared. And then finally, I get 3xy to the 3rd. Okay, so why did I write here x y to the 3rd? Why did I go in that order? Well, remember, our order said it needs to be alphabetical. And alphabetical, x comes before y. Even though y has a higher exponent in that case, I would write x then y. And so this would be my final answer. All right, example 11. I have a distributing problem that I need to deal with, and it's this 2y. But the trick with this one is that it only goes into the parenthesis terms it touches. I don't add it on to anything else. So I would have 2y times 6x minus 2y times 4x squared minus y. And then I have these other two terms, plus 13x squared y squared and minus 6. I'm not going to mess with those unless by some miracle I can combine like terms. So let's simplify what I've got. I'm going to write my 1 powers just so I remember them. And I see that 2 times 6 is 12. So I've got 12xy. Next term, with my ones that are listed there, I have a negative 8x squared, and I get y squared again. With a 1 power and a 1 power plus 13x squared y squared minus 6. Those didn't change. So now I've multiplied as much as I can. And just like before, I'm going to combine like terms, if I have any. Well, it just so happens I have a negative 8x squared y squared and a 13x squared y squared. My 13 kind of looked like a B. Let's see if I can fix that. 13x squared y squared. Those are like terms. What defines a like term again? Remember, they have to have what? Same variable and same exponent, which this has. This has an x squared, y squared, x squared, y squared. Whereas my 12 doesn't have either of those things. So my only terms I can combine are those two terms, and they also have the highest exponents. So when I combine these to get 5x squared y squared, the x squared and the y squared are my highest exponents. So they have to be listed first, then 12xy, and then negative 6. So we would get 5x squared y squared plus 12xy minus 6. All right, maybe you didn't get that one to begin with. So now hit pause and try 12. Try it all on your own. All right, here we go. I'm going to take negative 2 and I'm going to distribute negative 2 in. I'm also going to distribute 3m into everything in the parenthesis that it touches. That would give me negative 6m cubed minus 12 plus. Now I'm going to take that 3m and multiply by everything. And remember, this m has a little 1 there. So if I do 3m times 2m squared, I would get 6m to the third plus 3m times 3m would give me 9m squared. And then 3m times 1 gives me 3m. Well, now my job becomes a little bit more fun because my goal is to combine like terms. And if I know I want this in standard form, it means I want my highest exponent listed first. And the highest exponent that I see is an m cubed. And I have a negative 6m cubed. Oh, but I also have a positive 6m cubed. If I combine those, a negative 6 and a positive 6, I have 0m cubed. I don't need to write m cubed. It goes away. Then I'm going to look to my next highest exponent, which is this 9m squared. And then I'm going to go to my next highest exponent. Well, my next highest exponent would be something with m in it. And I see just a plus 3m. And then finally, I would go with any constants that I have, and negative 12 is the only one. So my final answer would be 9m squared plus 3m minus 12. How'd we do? So we've put into practice our exponent rules, and we're multiplying monomials by polynomials. All right, as always, you can hit pause, rewind, revisit those concepts that maybe cause you a little bit of confusion. Otherwise, you have an assignment that goes with 7-2 also. We'll see you soon.